Lesson 3, Graphing Radical Functions. Our essential question is, how can you use what you know about transformations of functions to graph radical functions? And here is our table of contents. Graph square root and cube root functions. We want to graph the function f of x equals the square root of 3x. What is the domain and range, and when is the function increasing or decreasing? So first, I want to make a table of values. So I'm going to pick numbers that I know when I multiply by 3 are going to give me whole numbers when I take the square root of them. So I'm going to start with 0. 0 times 3 is 0, and the square root of 0 is 0. Then I'm going to do 3 times 3, because I know 3 times 3 is 9. The square root of 9 is 3. Then I'm going to do 3 times 12, which gives me 36. 36 square root of 3, or square root of 36 is 6. And I'm going to do 3 times 27, and the square root of that gives me 9. So 3 times 27 gives me 81. The square root of 81 is 9. Then I'm going to go ahead and graph those points. So I'm going to graph 0, 0 first, then 3, 3, 12, 6, and 27, 9. Okay. And then I'm just going to connect those points. Since we are trying to find the domain and range, we can look at the x and y values. We know that we can't have a negative x value since we can't have any negative square roots. So that means that our domain for the function is x, where x is greater than or equal to 0. The range is very similar in the fact that since I can't have a negative value for x or be given a negative square root, I can't have a negative value for my y's either. There's nothing that would make one side equal to the other in that case. So the range is similar in that it will always give us a positive value. So our range is y, where y is greater than or equal to 0 as well. So looking at the function, right, when I'm talking about increasing or decreasing, I'm looking at the direction the function is traveling. So if I started at 0, 0, and I'm going to continue to go upwards and upwards, so that means that this function is increasing. Next, I want to graph the function g of x equals the cube root of 2x. What is the domain and range, and when is the function increasing or decreasing? So unlike with square roots or fourth roots or any roots that are even, we can have a negative number in roots that are odd. So third root, fifth root, seventh root, things like that. You can have an odd number because odd numbers, when multiplied, can potentially give you that negative value. Because if I multiply 3 times negative 3 times negative 3 times negative 3, I would get a value of negative 27. So I want to, again, make a table of values. So I've got negative 32. Okay, so again, I'm looking for something that when I multiply by 2 will give me a perfect cube root to make my life easier. So negative 32, I get negative 4. Negative 4, 2 times negative 4 gives me a negative 8. Okay, that's going to give me a value of negative 2. 0 is going to be 0. 4 gives me a value of positive 2. And 32 gives me a value of positive 4. Since we are dealing with a cube root, these values can either be positive or negative. So the next thing that I want to do is go ahead and graph these points and then connect them. So I start with negative 32, negative 4, negative 4, negative 2, 0, 0, 4, 2, and 32, 4. Okay. And I'm going to go ahead and graph these. So they're creating this almost S shape in their graph. So with this, when I'm looking at my domain and range, I'm looking again at my x values. I can put any value I want in for x, can be positive, negative, and I'm still going to get an output for my y value. So my domain is going to be all real numbers. It's very similar with the range. So my range can really be all of these real numbers. Okay, so both my domain and range are functions that have both all real numbers as domain and range. The function is increasing the entire time. So if I start on my left side, I'm constantly going up. I never actually go down, so I'm never decreasing. So this function is increasing. Radical functions. A radical function is the function of the form f of x equals a, the nth root of x minus h plus k, where a is going to be my vertical stretch or compression, h is my horizontal translation, so am I moving left or right, and then k is my vertical translation, am I moving up or down. Okay, this is very similar to all of the previous functions that we've had throughout these lessons. So when we're dealing with quadratic functions, things like that, they're all very similar in that A represents that vertical stretch or compression, H is that horizontal translation, and K is the vertical translation. Graph or transformation of a radical function. Graph g of x equals 2 times the square root of x plus 3 plus 5. What transformations map the graph of f of x equals the square root of x to the graph of g? How do the domain and range of g differ from those of f? So again, I'm determining where the differences are between f of x, my parent function, that's square root of x, and g of x, where it's 2 times the square root of x plus 3 plus 5. So the first difference I see is that 2. That 2 tells me, again, it's a vertical stretch or compression. In this case, it's a vertical stretch by a factor of 2. H, it gives me a plus 3, so it determines that horizontal translation. So I'm moving 3 units to the left. And the plus 5 tells me a vertical translation. In this case, I'm moving up 5 units. I then can create a table of values and use that as a guide to create my new graph. So if I have the square root of x, I'm using 0, 1, 4, and 9. Again, I'm using numbers that I know are going to give me a perfect square. Okay. So I have 0, 1, 2, and 3, and then I can go ahead and graph those. Because I am figuring out 2 times the square root of x, it's like multiplying each of my f of x values or y values by 2. Okay? So I can do that. My x values are staying the same. Whatever I would normally get for my y value, I'm multiplying it by 2. So I start with 0. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. Okay? So when I graph these, right, I'm graphing f of x first. I'm graphing the square root of x first. Okay. And then I'm going to graph that 2 times f of x. And again, you can kind of see that it creates this larger stretch at this point. So it's twice the size of my parent function. Okay. The next thing I'm going to do is I'm going to do that horizontal and vertical translations. Okay. So I'm going to move this up 5 units. So I'm going to take whatever number I had when I multiplied it by 2, and I'm going to add 5 to it. So 0 plus 5 is 5, 2 plus 5 is 7, 4 plus 5 is 9, 6 plus 5 is 11. Okay. And I'm going to graph those points. Now, granted, you don't have to do all of these steps. I'm not asking you to graph every single transformation along the way. You'll just need to complete the transformation at the end, but I wanted to show you the process to get to this point. Okay, so if this is helpful for you, by all means, please graph each individual transformation and translation so that you know exactly where your points are coming from. Okay, now that I've gone 5 units up, right, I've moved each of those pink points 5 units up. I'm going to move each of those points, the orange points, the new ones, 3 units to the left. Okay. So really, it's like saying I'm subtracting each of my x values by 3 units. So I start with my x numbers, 0, 1, 4, and 9, and I subtract by 3. So 0 minus 3 gives me -3. 1 minus 3 is -2. 4 minus 3 is 1, and 9 minus 3 is 6. Okay, and then I go ahead and graph those points. and connect them with a line. Now in my original parent function, right, my domain and range were both for values greater than 0. If I'm looking at this now, my domain and range are going to change slightly because I'm not starting at 0, 0. I'm actually starting at the point of -3, 5. So that's going to change my domain and range. So since I'm changing my domain and range, right, instead of for my domain, my greater than or equal to X values, they're now going to be greater than or equal to -3 values because that's where they start, okay? My range is going to be the same thing. Instead of greater than or equal to 0, it's greater than or equal to 5 because I can't put anything less than 5 or less than -3 in for Y or in for X because then I would get a negative number. Rewrite radical functions to identify transformations. How can you rewrite g of x equals the square root of 16x to identify the transformations from the parent function f of x equals the square root of x? So I want to use the property of radicals to rewrite the function and identify a vertical change. See if there's a vertical change. I know that I can rewrite the square root of 16x as the square root of 16 times the square root of x. Okay. I know what the square root of 16 is, which is 4. Okay, because 16 is 4 times 4. So since a equals 4, that tells me it's a stretched function vertically by a factor of 4. Okay. How can you rewrite h of x equals the square root of 9x plus 9 plus 2 to identify the transformations from the parent function f of x equals the square root of x? Okay. I'm looking at the same thing. I'm looking at what's underneath that radical symbol that I can simplify. What I can do is I can factor out a 9. Right? So I can rewrite this as the square root of 9 times the quantity x plus 1 plus 2. Okay. And then I can rewrite that as the square root of 9 times the square root of x plus 1. I know that the square root of 9 equals 3. So I'm left with 3 square root of x plus 1 plus 2. Well, that 3 out in front is now telling me that it's a factor of 3. So that's that vertical change. My horizontal and vertical translations are going to remain the same. Okay. So it's stretched by a factor of 3. It has a vertical shift of 1 to the left and a horizontal shift of 2 up. Write an equation of a transformation. What radical function is represented in the graph? So if I'm looking at this graph here, it's going to go through 0, 0. It continues into negative, so that tells me it has to be an odd root. And since we're only dealing with square roots or cube roots, I know it has to be a cube root. So the next thing that I'm going to look at is I'm going to look at what the parent function of the cube root of x looks like. Okay. In this case, it looks like this blue function, right? So it starts and it goes through -1, -1, and 1, 1. My function that I'm looking at that's already graphed goes through 1, 2, and -1, 2. So that tells me that there is some sort of vertical stretch or compression going on here. And since I'm stretching, it's further apart, it's going to be a stretch. Okay. So if I'm looking at this, I know that f of -x equals -f of x. So I know the function's odd. Like the graph of the parent function, the graph of this function is symmetric about the origin. So I didn't translate it anywhere. I didn't move it to the left or right. I didn't move it up or down. So it's still symmetric about the origin. Since I know that there is no horizontal translations or vertical translations, now I'm going to figure out how it's being compressed or stretched. So again, I'm going to check for that vertical and horizontal stretch. Okay. So I'm looking at this graph here. Again, I'm going from 1, 1 to 1, 2, and I'm going from -1, -1 to -1, -2. So I do see that there is a vertical stretch here. We can see that the new function is either been vertically stretched by a factor of 2 or horizontally compressed by a factor of 8. They really mean the same thing. Okay, so either transformation maps the initial graph to the same resulting graph. Okay. I want to identify that transformation. So again, the function g can be written as g of x equals 2 cube root of x or g of x equals the cube root of 8x. either will give you the same answer. Okay, because again, the cube root of 8 is going to give me 2. Okay. What radical function is represented in the graph? So this looks like a square root graph because it stops at a specific point. In this case, -5, -4. Normally my square root graph is going to start at 0, 0. So this means there has been a vertical and a horizontal transformation. So I moved 5 units to the left and I moved 4 units down. We can then check for a vertical and horizontal stretch based off of these numbers here. Looking at them, it doesn't look like it has been vertically or horizontally stretched or compressed. The points are very similar to each other. We've got this -4, -3, which is just one up and one over from my -5, -4 point. It's the same thing here with 0, 0 to 1, 1. So that means my function is going to be h of x equals the square root of x plus 5. So again, that horizontal translation of 5 units left minus 4, that vertical translation of 4 units down. Interpret a radical function model. Looking out to the sea, the visibility in miles from a certain spot on a cliff can be calculated using the function d of x equals the square root of 1.5x, where x is the height in feet above sea level. Sasha walks through elevations ranging from 5 feet to 40 feet above sea level. What are the minimum and maximum distances that she can see? So the first thing I want to do is I want to graph the function over the given domain. They told me the lowest visibility and the highest that she could see. So the lowest point is 5 feet, the highest is 40 feet. So I'm graphing this function square root of 1.5x from 5 to 40. So it looks something like this. From here, I'm looking at my minimum and my maximum distances. So I have a minimum at 5 and a maximum at 40. I can find what my minimum and maximum values are by either looking at the graph. If I'm using something like Desmos, I can use the find button on my calculator. If I'm not using something like Desmos, I can substitute those values in for x and simplify them using a calculator, which will give me my values, my minimum and my maximum values that I can see. Okay. So if I put 5 in, 1.5 times 5 is approximately 2.74. And if I do the same thing for my maximum value at 40, I get approximately 7.75. So my minimum and maximum distances that Sasha can see are approximately 2.74 miles and 7.75 miles. Summary. So in conclusion, with radical functions, again, a radical function is in the form of a, the nth root of x minus h plus k, where a is my vertical stretch or compression, h is my horizontal translation, and k is my vertical translation. We also have parent graphs of square roots and cube roots, okay? And they're going to differ and depend based off of what you do with that vertical translation, stretch or compression, horizontal translation, or vertical translation. And that is the end of Unit 5, Lesson 3.